Say you want a model to answer an open question by reading a whole pile of retrieved passages. The obvious move is to jam all of them into the encoder at once and let attention sort it out. But there's a wall waiting for you. Self-attention cost grows with the square of the total length, so the more passages you add, the more brutally the compute explodes, and you can only fit a handful before it becomes hopeless. Fusion-in-Decoder from Izacard and Grave in 2020 found a clever way around that wall, and it let retrieval-augmented QA scale to far more passages than anyone was comfortably using. Here's the trick that makes it work. To feel why this matters, put the naive approach next to what FID does. The straightforward way is to concatenate every retrieved passage into one long sequence and hand it to the encoder. Sounds fine until you remember attention is quadratic in length. Double the passages and you roughly quadruple the compute, so in practice you can only afford a few before it becomes hopeless. FID refuses that trade. Instead of one giant sequence, it encodes each passage on its own. Now cost grows only linearly with the number of passages. So doubling the passages just doubles the encoding work, and suddenly reading dozens or hundreds of them is completely on the table. Let's trace the whole flow, because the name tells you exactly where the magic happens. It all begins with retrieval. Given a question, a retriever pulls back many candidate passages that might contain the answer. This is the same first step you'd find in any retrieval pipeline. The difference is that FID is perfectly happy to take a large batch of them, because it won't choke on the count the way a naive encoder would. Here's the pivotal move. Each retrieved passage gets paired with the question and pushed through the encoder separately on its own. Because the passages never share one sequence, the encoding cost stays linear, and every passage gets its own clean, independent representation. Then all of those separate encodings get concatenated into one big pool of representations. Notice that nothing quadratic ever happened. We built a rich, wide view of everything the retriever found without paying the attention tax on the encoder side. And this is the fusion in the decoder, the step the whole method is named for. The decoder attends across that entire pool at once, weaving evidence from every passage together as it generates the answer token by token. That's where the model actually reconciles 100 passages into one coherent, well-grounded response, and it's why the answers keep getting better as you feed it more evidence. Strip FID down, and really just 3 ideas do all the heavy lifting. First, encoding each passage on its own scales linearly. By never fusing passages inside the encoder, you sidestep the quadratic attention cost, which is the whole reason you can afford so many passages at all. Second, the decoder does the fusing. All the passage encodings meet only in the decoder, where cross-attention reconciles them into a single answer. That name, Fusion-in-Decoder, is a precise description of the architecture. Third, more passages, better answers. FID can comfortably read 100 passages, and its accuracy kept climbing as you fed it more, which was a big jump on question-answering benchmarks at the time. Let's pull the key points together. The method, from Izacard and Grave, scaled retrieval-augmented question answering to many passages at once. Its core trick: encode each retrieved passage separately with the question, so cost grows linearly, not quadratically. Then the decoder attends over all the encodings together, fusing evidence into one answer. That let it read 100 passages efficiently, and accuracy kept improving with more. If architecture tricks like this are your thing, Standarity.com has plenty more AI explainers. Catch you in the next one.